Okay, so for this particular task, we're just matching the picture or the function with the name that it should be given, okay? And we've done a few worksheets about these, so you can go back in previous videos and see what kind of graphs are what, okay? And I'll go over the obvious ones, but I want to give you hints on some of the more difficult ones. Let's just kind of dive right into it. We'll go by the names here and then match the picture, okay? So number one says linear, okay? So the key word there is line, and all these are lines, but again, by a line, we assume that it means by a straight line. And look at letter F. Letter F has a nice straight line right there. So let's go ahead and say that F is linear. Okay? Let's go ahead and jump to quadratic, okay? We spent a lot of time with those in your IM2 days or earlier algebra days. And we know that for quadratic functions produce a parabola. So looking at all these, a parabola, again, is kind of that U shape. And look at letter C, the typical parabola right there. So quadratic is C. Okay, let's jump down to absolute value. We've talked about that in class. And absolute value, remember, has one of its distinct characteristics is that it has a sharp corner rather than a parabola, which letter C has a nice curve to it. Absolute value has a very sharp corner, so kind of like a V, so absolute value, a V has a very sharp corner. So, looking here at all my options, look at letter G. See how it goes down and makes a sharp turn upwards? So that would be a great example, or this is definitely a picture of an absolute value function, so letter G. Okay, and then radical would probably be the most other distinctive feature that we can look at here. So for a radical function, it's either going to start fast and grow slow, okay, and typically it's going to have it's definitely going to be more wide than it is tall. Most radical functions, whether square root, cube root, are going to start off, they're going to be very wide, meaning it's going to be stretched left to right as opposed to being taller going up and down. So looking at my options, okay, letter A looks like a good one, and letter H looks like a good one, okay? But the difference between the two is that, notice how letter A, see how it starts off growing and then it starts getting a little bit slower, okay? Letter H, one of its characteristics, okay, it starts below the x-axis, whereas letter A starts above. And if you remember our discussion with square roots, my answer can never have, the radical can never have a negative under it. So I have to be cognizant of that when I'm looking at these pictures. And so between A and H, if I had to make a guess, I would choose A for radical because, remember, some of the radicals can't be negative, okay? So those are the obvious ones that I wanted to go over with you. So let me just give you some hints here, starting with exponential. Okay, so for exponential graphs, typically as you go from left to right, the numbers that are negative, or where x is negative, meaning the negative x values like -1, -2, the graph is going to be very, very small, meaning it's going to be closer to a particular asymptote or closer to the x-axis. And then for exponentials, typically when it gets past the y-axis, or where x is 0 and x starts becoming positive, the graph is going to grow very, very quickly, or it's going to go up very sharply. Okay, so that's your hint there. So for where x is negative, it's kind of hovers near a particular line, typically the x-axis, and then when it gets past x equals 0, meaning where the x is positive, the graph shoots up really, really quickly. So I would take a look at letter D for that one. For number 4, polynomial, okay, so a quadratic equation has 3 terms in it, okay. Typically, if we remember the worksheet we've done, we've seen the equation of a quadratic. Typically, it looks like ax squared plus bx plus c, okay. And the exponent usually tells me, the highest exponent tells me that there's going to be 2 x-intercepts. Whether they're real or imaginary, that's us for to determine, but there's usually 2 different places where it's going to cross the x-axis. Okay, so a polynomial, rather than it being just in 2 places, it could be it could be 2 or more. So meaning it's going to have lots of twists and turns in it. Okay, so a polynomial is going to have a lot of twists and turns, which letter I and letter B definitely do those things. okay? But the difference between B and I, look at letter I. Do you see that it continues a pattern? Okay? So it seems to follow a pattern, but doesn't seem to grow or shrink past a certain point, right? It gets a certain type of height, and then it goes a certain type of low, okay? And that's a kind of graph that we're going to discuss later on this year. But you've seen a polynomial graph before, and there is a key feature to the polynomial graphs, just like a quadratic. The ends will either go straight up or straight down or in opposite directions, okay? Meaning up and down. So look at C. That's a quadratic. They're both going up. So use that as your hint. I would take a look at letter B for that one, okay? Rational functions, okay, that's something that I know you probably have never seen before. But a rational function, the one key characteristic about it, let's just go ahead and give you one, so 1 over x, okay? So it's a fraction. Now, it poses a situation because, remember your teacher always said we can never put 0 in the denominator, okay? They said that for a reason, and this is where we start to investigate why. Because if I put 0 in the denominator, that means it's undefined. And we talked about this in class. When something is undefined, something exists in that spot, meaning the graph cannot cross that particular thing. So I'm looking at all my options here. Is there a particular place where I cannot put 0? Meaning, is there a graph on this paper where the graph is not crossing what can't be in the denominator? So like we said, we can't put 0 in the denominator. Where does the graph not cross 0? I would take a look at letter E for that. Okay, logarithmic. That's something that we discussed this already. And something about logarithmic graphs, my logarithmic graph can never equal a negative number. Meaning if I take the log of 3, it's never going to be negative something. A logarithmic equation always has to equal a positive number. So with all my choices left, is there something where x has to be positive? Okay, just sort of like exponential graphs, logarithmic graphs, okay, are sort of the same way. I would take a look at letter H for that. And then trigonometric. So that's something that we're going to get to in this year as well. And trigonometric values, okay, they follow a pattern, or they have a certain type of rhythm, okay? And look for the graph that seems to have some type of rhythm. It repeats itself over and over again, okay? So those are a couple of helpful hints. I just wanted to kind of throw those out there, and I hope that helps you do your homework tonight.